Hello, my name is Stefan Heinzelmann, and today I'm going to show you the commissioning process of the brand new G115D drive system. Today's presentation we are split in two different parts. First, we'll take a look at the offline parameterization, where we will check out the parameterization as well as some preset applications that we have in there. And afterwards, we will take a look at the online parameterization for the motor-mounted version, which has the advantage that we don't have to do the parameterization manually. Instead, we connect to the drive and pull all the data from the pre-commissioned drive. Let's take a look at that.
For the parameterization process of a G115D, we have to open TR Portal, and then here on the starting page, we click on Add New Device. In this first window here, we can then give a name to this device, which will be G115D WM for wall-mounted in this case. And then from the list in the lower half, we can pick the device that we want to use. What we see here then as a blue outline is a placeholder for the drive, since we have not picked a specific drive yet. In the lower half, we see the wall-mounted and motor-mounted versions. So for this, we will stick to wall-mounted, and then we pick the specific device, in this case, the 0.55 kilowatts. In this list, we can see all the other power ratings that are available, as well as the MLFBs of those drives. Once we have selected our drive, we can then scroll down all the way on this page and click on the green Go to Commissioning button right on the bottom here. This will take us into the commissioning screen, and here we select the commissioning wizard, which will support us in the commissioning process. So the first page we see here is the control type page. Here we have the chance to select certain control types. For this example, we keep it in default setting though. The next page here then lets us select command sources, which as a default setting here is the field bus. This utilizes standard Telegram with extensions. If we continue then, we get into the drive settings. Here we can see specific information about the drive, and also we are able to select the pulse frequency here. Once we are done with this, when we click on next, we get into the brake settings. And as you can see, the brake is already selected. That is because the brake is pre-configured and parameterized from the factory. The next page then lets us select our motor. Here we have the option to select different motor types. We can both select Siemens motors, as you can see here, as well as third-party motors, which we can freely enter data in the top row. For this example, of course, we will use a Siemens motor, in this case a 2kJ8 motor. This one is also available as a reluctance motor. For this example, though, we will use the regular asynchronous motor. Once we accept this, we then get into the selection, which is done via the MLFB. So we enter the parts MLFB, and this brings in all the motor data into our system. Once this is done, we can accept on the green button on the right, which will bring us to the next page. Here on this page, we can then see all the data that we entered. We can check this again. We see the relevant motor data, like the speed, as well as a temperature sensor that is pre-configured for this motor here. Once we accept this, we see that there also is a pre-configured motor holding brake, which also is part of the motor and pre-configured from the factory. We can also see the brake opening as well as closing times here. Here on this page, we then see some data regarding the motor. That is the maximum speed, that's the most important. We here have the chance to increase the maximum speed to 120%, which will give us 20% of buffer when we run the motor. On the next page, we are then able to select drive functions. We will leave this one as a standard drive. We could also select pump or fan applications here. On this mask, we're then able to select an encoder, which utilizes two digital input outputs to give us information about the rotational position of the motor. We have the chance to enter the data of our encoder here. In this case, we don't have an encoder though, so we don't select this box. The final page we get here then is our summary page. Here we can see all the information that we entered. We can check this again and make sure that everything is correct. And once we accept this, we get back to the starting screen, which means that we successfully parameterized our drive.
So the first pre-configured application that we have is the conveyor. So as you can see here on the slides, usually that is a part or goods that are moved on a conveyor in one or two directions. Then we have an acceleration and a deceleration ramp for the speed of the application, and multiple trigger sensors to stop and start the application. This is like typical use cases are in like parcel centers, production lines, or intralogistics applications.
After the general parameterization process of the G115D is done, there is pre-configured applications which we can use to easily set up the system. So for this, we first click on parameters, then we go to the application function, and in here we select the conveyor technology. In the default setting, there is no conveyor technology selected. If we open this drop-down menu, we have the chance to access the different applications. The applications that we have here are a conveyor, a turntable lift, as well as a trolley application. We will take a look at all of these applications later, but for now we will pick the first one, which is the conveyor. And then once the page opens, we see the first application example. That is the conveyor, which is also the simplest application that we have. The picture here shows the basic setting of that conveyor with like one start and stop switch. If we go on graphics view here, we can see the acceleration or the speed graph of this application. On the left side of this graph, we can see the acceleration ramp. So that is the acceleration of the conveyor once it speeds up until its designated speed. That speed is communicated via the field bus system that we see on the right here. From there on, once the conveyor reaches its designated speed, it will continue on this specific speed until the stop switch is enabled, which we can see on the right. This stop switch will then trigger the deceleration ramp, which will slow down the conveyor at the designated rate until it reaches a standstill. What we still have to do now is we have to select a sensor. So we open this drop-down menu here, and there we search for parameter 722, which is our digital inputs, and then we can choose input 0, which will then be used as the input for our stop sensor. The third setting that we have here then is our trigger type. Here we can select how the stop switch is triggered. So we can select both level as well as an edge detection, and both of them we can use the positive as well as a negative edge. And last but not least, we have a bypass system here, which enables us to bypass our stop sensor. This so-called override signal, which is also communicated over the field bus, enables us to temporarily disable this stop switch function. This will be useful when we want to transport goods without stopping at a switch or a photoelectric barrier. This of course can also be set to any digital input, so we can use switches or whatever we like to bypass the stop switch. If we then go back to the starting screen, we here have the possibility to switch between high and low speed, which is very helpful when we have a conveyor that we need to switch in between two speeds. For this, we have this high-low speed checkbox here, which enables us to use the pre-configured settings to set this up. When we click on this, as you can see here, we introduce a second sensor. When we go on show graph now, we can see that the graph changed to a 2-speed setting. So like before, we have the acceleration ramp to the set speed on which the system will run, checked via field bus until we hit the first low speed switch. This switch we can configure on the right side here. Once that sensor is triggered, we then get into the deceleration ramp, which will lower our speed to the low speed setting. And again, this sensor can be parameterized just like we did before. And then once we eventually get a signal for the stop switch, we get into the final deceleration ramp, which slows the motor down to a standstill. In addition to this, we can switch between 1 and 2 directions, which then also will change the graph that we see. If we go back to the main screen now, we see that we have introduced another pair of sensors, which is for our second direction of movement. Of course, these two new sensors that we just introduced have to be parameterized as well. So we would do the exact same thing as we just did for the other direction of movement and the two new sensors. And after this, the entire conveyor setup is finished.
Another application that we have is the turntable application. This is usually used when we have goods that are moved in one direction that we have to direct into another direction. So we have like 2 or 3 positions in which we move the part, usually a switch between high and low speed and certain end switches for the position. This is used for like pallets, parcel centers, or typical in storage units.
The turntable is another preset application that we have in TIA Portal. So as you can see here, the overall look of the system is the same. In the basic configuration, we have a 2-position turntable. So we have 2 sensors for the positions. Again, we will get a trigger signal from the PLC, which will start the movement, and then the turntable will rotate in between these 2 positions. On the right-hand side, we again have our parameterization as before, which correlate to the 2 sensors, which are marked A and C in this case. And again, if we click on graph view, we see the speed graph with our acceleration and deceleration ramp, as well as a set speed.
Another preset application that is pretty similar to the turntable is the Turntable Lift, which combines the function of the turntable of rotating goods with the lift motion. This is typical for pallet centers, where we move a pallet on a tray or a conveyor, lift it up to somewhere else, and rotate it on another slide. For this, we have the 2 movements, the rotation as well as the lift movement. We also have like a high and low speed switch, and usually we have 2-position movement.
A slightly more complicated application that we have is the corner turntable lift, which combines a turntable with a lift movement of a part. And again, we have our end positions marked here, which in this case are a lower and a upper position. The parameterization is again done on the right here, and also we have here the chance to enable or disable the end position. So in default, this is enabled, which means that the corner turntable will shift in between the 2 positions. There are some turntable lifts though which allow for unlimited rotational movement. In this case, we disable the end position function here. And again, we have the ability to switch between high and low speed, which will give us the same speed graph that we've seen in the applications before.
The final preset application we have is the traveling trolley, which is typical for picking applications where we move in goods on one belt and split it up on multiple belts. For this, we usually have end switches that give us the position where the traveling trolley needs to stop. Also, we have a high and low speed switching, and then we can do positions in between the belts via PLC. Typical use cases for this are parcel centers or even airports where you use it to distribute luggage.
If we select this, as we can see, the graphic changes a lot. So now we see the trolley system, which moves goods into different lanes. For this, our goods are moved from one of the lanes onto our trolley. Then the trolley moves them to another position, and they are moved from the trolley to the other lane again. This application only takes care of the lateral movement of the trolley, not the movement of the goods onto the trolley. For this movement, we have to use a separate drive. For this application, we basically start with the goods on our trolley, which is our trigger point that we get from a PLC, and then the trolley moves the goods to another position where they get unloaded again from the trolley onto the lane. There is no fixed amount of lanes, so we are able to select these freely. The function to find the lanes itself, though, is not implemented into the drive. This is a function that we have to run on the PLC. One function that we have on the drive, though, is the stop sensor override function. This function is used to run over one or multiple lanes. So our PLC uses this command basically to jump over a lane. So in this case, if we want to move goods from the left lane to the third lane, we would use the stop sensor override function in our PLC to bypass the second lane. And then once we reach our final position, in this case the third lane, our PLC will deactivate the stop sensor override function, which will get us back into normal running mode. In addition to this, we can see two stop sensors here, C and A, which indicate the end of our total trolley movement.
All right, so now that we've seen the commissioning process for the wall-mounted version, let's take a look at the motor-mounted version, which has the advantage that we don't have to do the parametrization manual. Instead, we can go online, pull all the data from the drive, and have that into our portal right away.
For the commissioning process of our motor-mounted version, we can utilize the online parametrization, which enables us to connect to the drive and pull the relevant information straight from the drive instead of manually entering it into the system. In order to do this, we first have to assign an IP address to the drive so that we can connect to it. This is done in the functions block of the accessible devices. In this window, we can then assign an IP address as well as the subnet mask, which will be used to connect to the device. We confirm the entered information by clicking on the Assign to Device button. We then update the accessible devices to check if the IP address that we just assigned is accessible. Via the diagnostics function of the accessible devices, we can then under Diagnostics General check the designation as well as the serial number of the device that we assigned the IP for. Also, we are able to see the firmware of the device here. If we then click on the Functions button and click on Assign Name, we have the chance to assign our name to this drive, which will make it easier for us to find the drive in our TIA portal later. And as we can see on the left here, our name just changed to the assigned name, G115D motor mounted. By right-clicking on the device, we are then able to go on Upload from Drive, which will enable us to upload the information from the drive to our programming device. This process will take a few seconds as we are pulling all the relevant data from the drive via our IP connection. We can then close this window and go to our drive, which popped up in TIA Portal now. Here we can now see the drive, and if we open up the detailed view and click on properties, we can see the MLFB number that was automatically pulled from the drive. In addition to this, we can see detailed information about both the motor that we use as well as the gearbox, which in this case is a belted gearbox. We can now go online, which will change the color scheme and the look of TIA Portal. As we can see on the red marker on the left, there is some issue, which in this case is an active alarm. So if we go on online diagnostics and then active alarms, we can cancel these alarms in here. And as we can see now, the color changed to green, which means that we are already in set. If we click on parameter and then on configuration summary, we again get to our summary where we can show all the setup that was done, look through the data and check if everything is correct. Here we can see information about the motor, which shows us that we use a reluctance motor, as well as about the control unit, which in this case is our G115D motor mounted. We also see the order number, the control type, as well as all the settings that are set on the drive. And with this, the parameterization process is pretty much done.
Okay, so this was today's presentation. Thank you very much for your attention. If you have any more questions, please feel free to ask them to my colleagues right after this presentation. Thank you.
Siemens. Ingenuity for life.